Yes.
You said that stress is in equilibrium shows right hand side as zero. Where we can see the right hand side as zero.
Yes.
So that implies in terms of acceleration what this strain rate square is.
There is no acceleration.
Is strain square rate of change strain double dot is
Strain double dot
something like that.
or strain dot.
Strain double dot is zero.
That will be acceleration. Huh.
Zero.
It will be zero. Velocity is also zero. Dot is also zero. Have I started this thing? Yes. Let's start. Okay, let us begin again. So we'll now go on to thick walled pressure vessels directly. So let's start from, let's keep this equation and let's start with here. So this is the cross section, okay? The longitudinal cross section of the thick walled pressure vessel. This is the gap within which the fluid may be present. These are the thick walls, okay? And we'll understand that this radius is Ri and this radius is Ro. Okay, the internal radius and the outer radius. All right, the inner radius and the outer radius. Now see, the pressure here in general may be acting from the inside due to the pressurized fluid. It may also in general be acting from the outside. Okay, for example, in the case of the submarine, okay, you have enormous pressure from the outside. So you have pressure from the inside like this. This pressure is given by Pi. And there is pressure from the outside also. This pressure is Po. Now, you are just about to learn something extremely important. You are already familiar with it, and that is the condition of plane strain. I have mentioned this earlier. Okay, so when you have plane strain within the xy plane, then you have epsilon zz equal to 0, epsilon zx equal to 0, and epsilon zy equal to 0. When you have plane stress, then you have sigma zz equal to 0, sigma zx equal to 0, sigma zy equal to 0. These things are important for your life as an engineer should you choose to become a mechanical engineer, and it is also going to be important for the remaining of all your class tests, the class test 3 and the class test 4, as well as very importantly for your end semester also. So both for professional life as well as for examination purpose, plane stress and plane strain, the distinction and the application of those things, these are absolutely important. Now when I was your age, I always used to get confused between the plane stress and the plane strain. Okay, which one is what? A very easy, functionally, operable way of remembering it like what situation you are dealing with, is to think of it like this, that if you have a thin plate like situation, like a thin plate, okay, thin plate which is loaded in its own plane, that is a case of plane stress. Okay, and if you have this kind of a situation which is a long member, a long mechanical member, then in all likelihood, like you'll have to be a little bit careful, but in all likelihood that would be a case of plane strain. Now just because a member is long does not mean that it will be plane strain. There has to be extra conditions, of course, but what I'm trying to say here is that if you have a thin plate, it is not going to be plane strain. Okay, if you have a thin plate, if any plane is going to happen, it is going to be plane stress. And if you have a long member, if any plane thing is going to happen, it is going to be plane strain. Okay, but खत्म नहीं हुआ है भाई, बोलने ठीक है. So plane strain will occur in these kinds of long members when you have two conditions fulfilled. First condition is that there should not be any force component in the longitudinal direction. I repeat, there should not be any force component in the longitudinal direction. Please write it down. There should not be any force component in the longitudinal direction, which you can clearly see here. There is no force component in the longitudinal direction. All the forces that are there due to the pressure, they are acting in the radial direction. Okay, so the first condition for plane strain to be applicable is that there should not be any force in the longitudinal direction. Written? Okay, which is valid here. Just check. So all the pressure, the internal pressure and the outer pressure, they are acting in the radial direction. Okay, there is no component of the pressure in the z direction. Fine? Okay. The second condition is that even if you have pressure which is not along the z direction, you have the radial pressure, but in a very general situation, it could be possible that this pressure is not uniformly distributed like this. Rather, it has a variation in the z direction, meaning that you have smaller pressure here and very large pressure here. Still, it is valid that there is no force in the z direction, but there is a variation in the z direction. So that condition is also prevented. If you have such a condition that there are variations in the z direction, you are not going to get plane strain. Okay, so please write it down that there should not be any variation in the z direction. So first condition was that you should not have any force in the z direction or the longitudinal direction. And the second condition is that there should not be any variation in the z direction or longitudinal direction. Okay, there should not be any variation in the longitudinal direction. These are the two important things. Okay, now because we are repeatedly saying in the longitudinal direction, there has to be a longitudinal direction available, right? That kind of a longitudinal direction will be available only if you have a long member. If you have the thin member, of course you have the direction, but nothing is there in the longitudinal direction. Okay, if you have like the plate from which you eat, not the mess plate which has holes, okay, is like refugee camp. Okay, so for 9 years I ate from that plate. So I know the pain. I got so used to it, I kind of half expected my mother to serve on that plate when I go home. Okay, forgot how to eat from a normal plate like a human being. Anyway, so that will not be your mess plate is not an example of a plane strain or neither of plane stress. वो कुछ भी नहीं है. It's like a complicated solid mechanics problem. Okay, so neither of this. So, and there is an entire body of problems which are neither plane stress or plane strain. It is not necessary that every solid mechanics problem can be classified as a plane stress or plane strain. Okay, but many can be. So tell me, here is plane strain valid? There is no variation of the pressure in the z direction. There is no force in the z direction. So plane strain is valid. Okay, so this is a condition of plane strain. That means that this thing, the del z of anything will be equal to 0. Let us now talk about the displacement components. Okay, let us talk about the displacement components. Now, because it is an axisymmetric situation, a thick walled pressure vessel, okay, so it is better, the natural choice for us is to deal or to use the r theta z coordinate system. We can use, if you want, you can use the xyz coordinate system, and for certain problems that will be actually useful. My PhD students also, like, their bread and butter is to deal with axisymmetric problems. Okay, but in certain situations, we have observed that it is easier that if we use the XYZ coordinate system, because certain axisymmetric problems, as the geometry evolves, it does not remain axisymmetric, then it is better to use the XYZ coordinate system. But we will not have any of those complications here. So we are going to talk about the U, V, and W. These are the displacement components. I repeat, these are the displacement components in the r, theta, and z directions respectively. Write it down. U, V, and W are the r, theta, and z direction displacement components. Now, in general, this U will be a function of r, theta, and z. This V also will be a function of r, theta, and z. And this W will also be a function of r, theta, and z. If you have a general solid mechanics problem, this is the situation you are going to start out with. Any solid mechanics problem. Okay. Like if you are a sadist, well, not a sadist, sadist would torture others. If you are a masochist, like you like to torture yourself. So, okay, so if you're a masochist, then you take up your mess plate and you would use the r, theta, z coordinate system to analyze it. Okay, but let us assume that you are not masochist. So here, in this case, plane strain is equal to this del z equal to 0. So this dependence on z goes away. Okay. Furthermore, in general, it may be possible in certain plane strain problems to have a non-zero value of W. But it is very common and it is certainly true. We continue. Okay, last time it was Arjun, this time it is Bhim. Because Bhim copied from Arjun. If Arjun can play, practice bow and arrow in the night, I can also eat at night. So in the dark, he's sitting from a pumpkin. Or maybe watermelon, something like that. So, so W, okay. So W will be equal to 0. In general, it is not necessary. There is going to be 0, but we'll say that for this situation, W is 0. Basically, what are we saying? That the thick-walled pressure vessel, it is not going to elongate like this. Okay, it is not going to elongate like this. That's all we are going to say. So this is a major simplifying assumption that W is equal to 0. Okay, it is not a very trivial assumption to make. You have to have some understanding of the actual mechanical or physical situation to be able to conclude this thing. Yes.
So W equal to 0 is a necessary condition for plane strain, or we are just taking it for?
We are taking it as an extra simplifying condition. Okay, in all plane strain problems, in a general plane strain problem, it is not necessary that the W has to be 0. Okay, all right. So we have these things. So U is a function of r and theta, V is a function of r and theta. Both are independent of Z. Now what we are going to do is, we are going to make it even simple. Till now we have only utilized the plane strain condition. But let us not forget that it is, after all, an axisymmetric problem. Now remember, in the context of thin-walled pressure vessels, what did I tell you? A problem will be axisymmetric. Not just because the geometry happens to be axisymmetric. So this chalk has an axisymmetric geometry. Okay, it has an axisymmetric, forget the top, okay. So a fresh chalk, that is an axisymmetric geometry. Okay, this is an axisymmetric geometry. But if I hold it like this, make it a cantilever beam, and then if I load it like this, it is no longer an axisymmetric problem. It is still an axisymmetric geometry, but is no longer an axisymmetric problem because the loading is not uniform along the this theta direction. But in this case, it is an axisymmetric geometry, the loading is also axisymmetric. Therefore, it is an axisymmetric problem. And if you have an axisymmetric problem, what is the immediate conclusion that you can draw? Very good. Very good. Del theta is equal to 0. Okay, axisymmetric problem. So what does it mean? First of all, axisymmetric geometry. Plus axisymmetric loading. So these things, they together imply that the del theta is equal to 0. Del theta is equal to 0. So earlier we had del z equal to 0, now it is del theta equal to 0, which means that the dependence of those two displacement components u and v that we had on the theta, that also goes away. Okay. Furthermore, okay, let me not get ahead of myself. Oh, I don't want to. कहाँ लिखूं भाई? I want to keep that equation.
For this also we use the generalized Hooke's law.
Yes, yes, generalized Hooke's law.
So if we use the generalized Hooke's law, then we would have a value of EZZ.
Epsilon zz. We'll see.
That would give rise to a W.
We'll see.
That is W.
We'll see what happens. We will not hide behind anything. Okay. All right. So, so this u, this theta dependence is also gone. Okay, z dependence had gone earlier. Now theta dependence is also gone. V, this also. W we had already said was 0. Till now we have not gotten rid of V. Now back in the thin walled pressure vessel, what was the argument that we used to get away with V? Do you remember? The argument we used was that there is no loading in the theta direction. All this while we have only been arguing about the axisymmetry, but we never mentioned regarding the loading. I just try to, I'll try to remind you. So when you have the torsion problem, the torsion is still axisymmetric, but you do have a loading in the theta direction. Okay, you do have a loading in the theta direction, because of which the V component of the displacement, that is the displacement component in the theta direction, is not 0. Okay, but suppose you have a problem where there is no loading in the theta direction. Okay, I'll write this explicitly. No loading in the theta direction. This will give us the condition that V is actually equal to 0. Okay, so this is unlike it. So jao. So because there is no loading in the theta direction, we'll conclude that V is equal to 0. So it is unlike the torsion problem. All right. So ultimately, what do we have? Ultimately, so all that stands in front of us is this. U as a function of R, V is equal to 0, W is equal to 0. See how beautiful it is. Yes.
So that non-dependence on theta was because of that equation, that theta equals to 0.
Yes. But see, you can have a V which does not depend on theta, but which itself is not 0. Absolutely, right? Okay, so we have this simplified scenario. This is pertaining specifically to the case of our thick walled pressure vessel with all its axisymmetry and all other conditions. Now we are going to try to simplify this. So what will you do? One by one, we'll consider our strains. Plane strain We have already seen from the strain chapter, it implies what? Epsilon zz equal to 0. Now, back then, when we were using the Cartesian coordinate system, we wrote epsilon zx equal to 0 and epsilon zy equal to 0. By the way, for your benefit, for the coming class tests and everything, if what I am saying right now, you are not very confident with, कि क्या बोलते जा रहा है प्लेन स्ट्रेन, क्या बोलते जा रहा है प्लेन स्ट्रेस, बीच बीच में प्लेन स्ट्रेन, बीच बीच में प्लेन स्ट्रेस, if it feels like that, okay, because I used to feel like this, sometimes प्लेन स्ट्रेस इसके में, sometimes प्लेन स्ट्रेन की आदमी पगला गया है, ठीक है. So if you're feeling like that, you make a mark in your copy. Okay, I am not saying trust me or complete nonsense. You revise it a little bit, it will come back to you. Okay, and there will be definitely questions where you will have to distinguish sitting in the examination hall between what is a plane strain and a plane stress. Okay, there should be absolutely no confusion regarding this thing. I am saying this very, very important. Okay, and later also as an engineer, you should be able to distinguish it, but first of all, tackle your exams. Okay, so in the Cartesian coordinate system, this was epsilon zx equal to 0, epsilon zy equal to 0. We are no longer working with the Cartesian, we are working with the cylindrical coordinate system. So this will be epsilon zr equal to 0 and epsilon z theta equal to 0. Okay, very good. Now, this epsilon zr equal to 0, what does this imply? If we use the generalized Hooke's law, then tau zr is equal to what? Tell me. 2 दिन बाद एग्जाम है, टेस्ट है. What is tau zr in terms of epsilon zr? 2g epsilon zr. See, these things should be absolutely clear, I'm telling you. Okay, I mean, it should not be the case as you are IITians. Done a solid mechanics course, and the relation between this thing is not, I mean, I know memory is not everything, but something should be at your fingertips. Okay, so tau zr is equal to twice g epsilon zr. Epsilon zr is 0. We have already said that. Therefore, tau zr is 0. What is the consequence of this? Consequence is that, so I have the luxury of writing in this very wide board. You write back these equations again. You write, considering this equation again. Write it. Everyone in your copy you write. Considering again this equation. लिखो, फिर से लिखो. Considering this equation again. And then you write this equation. So after writing that, tau zr equal to 0 following from the plane strain, you write considering this equation again. And then you write this equation. Quickly, write this. Yes.
Sir, are there any lectures left which are left to be uploaded and they are coming in the after tomorrow's test?
No.
All have been uploaded.
So what is left is combined loading that I have not uploaded, but that is not there in the CT3. Syllabus for this thing is buckling, stress and strain. All those are uploaded. Okay, now you tell me from these equations what are the terms that I can drop. First of all, you see this del theta term is here. We have already accepted that we are working in the context of an axisymmetric problem. So del theta of anything is equal to 0. So this thing drops out. Okay, this thing drops out. We have the del tau zr del z. We have already proved that tau zr equal to 0. That follows from the plane strain condition. So this thing is 0. Okay, nothing else is 0. So what we have from the R component of the stress equilibrium equations is the following equation.
Sir, sir, even if tau zeta was not zero, then also that term would be zero, right? And for plane strain,
For the plane strain, yes. Yes, very good. Hmm. But this is a stronger condition, the tau zr. Okay. Now, please put a nice big rectangle. Okay. Again, put stars and balloons around it. Put colors around it if you have colors. Okay. This is, I mean, one of the most important equations. In the cylindrical coordinate system, you have this. When you work with the spherical coordinate system and you have the entire spherical symmetricity, there is only one little difference. There is a 2 in front here. Okay. So it just happens, and because of the algebra, it just comes out like that. Anyway, now one personal remark, I have made half my career based on this equation. Okay, so the half the research that I do is based on this equation. Of course, it is not in the context of this small deformation theory with this small epsilons and all these things. There are other complications, but ultimately, the problems that I do with my PhD students, with your seniors, undergraduate, the BTech projects that I do, the master's project that I do, or that I guide, they are based, half of them are based on this equation. Okay, so it is that important an equation. Not just me, okay, many people do that. Now, we have to solve this equation. Okay, we have to solve this equation. Now see, we are at the same kind of problem that we faced earlier. When we took all those 3 stress equilibrium equations, we had to deal with the 6 unknowns. Now this is a single equation containing 2 unknowns. What are the 2 unknowns? Sigma RR and sigma theta theta. Okay, so we have to introduce more equations. We have to simplify it so that ultimately we have the equality between the number of equations and the number of unknowns. Okay, so now you'll see how nicely it shapes up. Sorry? Sigma theta theta is non-zero. It is absolutely non-zero. Like very much non-zero, strongly non-zero. Okay. So to get the physical feel of it, suppose you have a cylindrical pressure vessel and it is pressurized from the inside. So it has a tendency to burst open like that. When it has a tendency to burst open like that, there are stresses in the circumferential direction. So that sigma theta theta represents the stresses in the circumferential direction. So without even doing a single bit of maths, you can kind of visually see it. Okay, so what we'll do now is quite a bit of algebra. Okay, so here we go. So what was our plan earlier? When we had that discrepancy in our balance sheet, in the number of equations and the number of unknowns, we introduced more equations. What was the first set of equations we introduced? The strain stress relations. Okay, so we'll stay honest with that. We'll do with the strain stress relations. So following again the generalized Hooke's law, from now on we'll try to avoid as much as possible any kind of assumptions. Let's see how much we can proceed with that. Can we do any simplification with this? No, sigma zz is not 0. We are not dealing with plane stress. We are dealing with plane strain. The only thing that we can say to be 0 is epsilon zz. That is not present in this particular relation. Okay, so nothing can be done as such with this. Let us write the next equation. Can we do any simplification with this equation itself, or maybe in conjunction with the previous equation? Not yet, because we still don't have the presence of the epsilon zz. Next, epsilon zz. Here we can use a simplification. We have already said that we are going to accept, or we are going to model the thick walled pressure vessel as a plane strain problem. And because it is a plane strain problem, the epsilon zz is equal to 0. If the epsilon zz is 0, then you can do something very nice with the right hand side. You see, we can immediately conclude that sigma zz is equal to nu times sigma rr plus sigma theta theta. General life lesson. If we were not working with the r theta z coordinate system, rather we were working in a different problem, also plane strain, but in the xyz coordinate system, then also it would have been the same situation. Instead of sigma rr and plus sigma theta theta, what would we obtain? We would obtain sigma xx plus sigma yy. Do not forget this. Okay, do not forget this. Near this you put a star. Dozens and dozens of your seniors have made mistakes in these things. For problems like significantly long problems involving these kinds of concepts, which have to do with me testing, whether when we are testing your knowledge of plane stress and plane strain. Suppose you do everything correctly, but that fundamental understanding is lacking between the plane stress and plane strain. Immediately half marks gone, not 0.5 marks. In a 12 mark question, 6 marks gone. Okay. Okay, what do we do with this? Well, you are all masters of algebraic manipulation. Because we have obtained sigma zz in terms of sigma rr and sigma theta theta, what we can do is we can plug this relation back into this. Okay, we can plug this back into this. Do it. Do it yourself. Tell me what you obtain for epsilon rr and epsilon theta theta. This is something which you have to do repeatedly from now on. So please get into the habit of doing it. Also in the case of plane stress. See, in the case of plane, everyone just pause for a second. In the case of plane stress, it is relatively easier. Why? You can directly set this sigma zz as 0, this sigma zz as 0. Because plane stress implies sigma zz equal to 0, sigma zx equal to 0, sigma zy equal to 0, or tau zx, tau zy. Okay, so it's simpler. Anyway, do it. Tell me the relations, epsilon rr and epsilon theta theta. I'm waiting for your answer.
By sigma r
1 minus nu square. Okay.
minus
Minus. Okay.
u plus u square sigma
Nu plus nu square sigma theta theta. ओके, ठीक है ना? What to do now? You want to add them? Yeah, we can add them because it will look nice. Huh? So, what Akshat is suggesting, it's a very nice teachable moment. So, for these kinds of problems, okay, you will have temptations, okay, along the way of doing this mischievous thing and that mischievous thing because your brains are highly evolved in terms of mathematical manipulation, okay, because JE advanced. Okay, किसी तरह आंसर लाना है. Answer also what your universe for every those 3 minute micro increments of your life, your entire focus, your entire life force was dedicated to those three options and probably none of the above. Okay, so life is not like that. Okay, so my suggestion here is that don't go for these kinds of mischievous manipulations. Okay, those have a time and place, but for these problems there is a certain sequence of steps that you have to follow. If you follow that, bypassing all the little algebraic temptations, you see that ultimately सब कुछ अच्छा ही होगा. Okay, ठीक है. So don't fall into the temptations. I'll show you the way to do it because these are very standard things. We do not have to rediscover fire here. Okay, every time we do a problem. So what we'll do now is that we will look at these things and stay very happy, but also appreciate the fact that our system of equations is not closed. Okay, so we are at the same level of problem that we were earlier. We have less number of equations compared to the number of unknowns. Okay, so what we'll do, we'll have to bring in the strain displacement relations, but before that one thing we'll do. I mean, not to completely disrespect what Akshat suggested, but in a slightly different way. To see clearly what we want, what we'll do is, we will, from these two things, we will solve for the stresses in terms of the strains. So currently, what we have in front of us are the strain displacement relations. From the the strain stress relations. From these, what we are going to obtain are the stress strain relations. So basically invert them. Do it. So find sigma RR and sigma theta theta in terms of epsilon RR and epsilon theta theta. Please do it. What Akshat was suggesting, you would have certainly gotten the sigma RR minus sigma theta theta, but you'd still anyway have to solve for the sigma RR. So as I said, conservation of difficulty. As these videos are being recorded, to future generations it will appear there is only one student in the class. They will keep on searching, ये अक्षत जनाब है कौन? Occasionally, Charit, and some caustic remarks to the girls. Are you in my section? Are you in my section? No, madam. हाँ? और थोड़ा आया करो क्लास में. Shamrat, this is extremely important for you. You realize that, right? Tell me quickly. Masters of algebraic manipulation. What is sigma RR and sigma theta theta? Tell me. Yes, sigma RR equal to? Try to bring it in this form.
R into 1 minus
Try to bring it in this form, please. Okay. Then
ERR into 1 minus
ERR, epsilon RR,
into 1 minus
into 1 minus nu. Okay. 1 minus nu into epsilon RR plus
theta theta into nu into
plus nu into epsilon theta theta. So thank you, Charit. Let your name go into the video record. So it's the same form will be for sigma theta theta. So everyone please check. Charit, please check if the corner thing is coming, the edge thing, it is coming, right? Okay. So this is correct. Okay, you have this. Now what do you do? So like good boys and girls, you take those two relations and substitute here. Okay, there is no other way. Which is why when we are doing solid mechanics problems at the professional level, we don't do these things by hand. Okay, so when you have to do all these algebraic manipulations, nowadays we don't do these things by hand. Nowadays means for the last, about 20 years or so. Okay, so what we do is use tools like Mathematica or symbolic Python for all the algebraic manipulations.
Sir,
Yes.
if you had to put the epsilon RR directly, then you could have done that in the first time.
Which one?
At the end.
So no. I know it is very funny. It is very funny. कि अब तो सर की लग गई. But the thing is, you have to give the boundary conditions also. So later on, you will anyway require this. As I said, na conservation of difficulty. Cannot bypass this thing. Acha. So substitute here. Okay. Or any other method that you choose, substitute here and find out. Actually do one thing. It will be a little bit easier. We have obtained the stress strain relations now. Okay. One last thing which we are going to use, if you look back at that balance sheet thing, what did we do? Just turn back and tell me. The strain displacement relations. Okay, the strain displacement relations. Now, what are the only two strains that are surviving? What are the only two strains that are surviving? Epsilon RR and epsilon theta theta. Okay, so we only have to deal with these two things. Epsilon RR and epsilon theta theta. Go back to the tutorial sheet number 7. Last question. If you do not have the sheet, take it out from your mobile phone. Go to tutorial sheet number 7 on strain and look at the last question. Last question. There were 2 pages. Did you find it? Found it? Okay. So that problem dealt with the strain displacement relations in the polar coordinate system. Polar coordinate means it is basically the cylindrical coordinate system only, but without the z. But here we have already found that there is no variation in the z. Okay, so z is practically gone. So what is the expression for epsilon rr? Del u by del r. What is the expression of epsilon theta theta? 1 by r del u del theta plus v by plus u by r. Okay. So 1 by r del v del theta plus u by r. But del v del theta means what? V is 0 itself plus del del theta is also 0. So ultimately what you have is just u by r. Okay. So for here, I'm going to say that you refer to question number 14, right? What is the question number? 14. Okay, tutorial sheet 7, question number 14. Now, just tell me something very quickly. Is this partial derivative making any sense? What did we find earlier? U was a function of r, theta and z initially, but the z dependence fell away, the theta dependence fell away. Ultimately, we were left with u is a pure function of r only. If u is a pure function of r, it doesn't make any more sense to write with this partial derivative. Partial of what? Okay, it is basically an ordinary derivative. Since u is a pure function of r. Epsilon theta theta, you please note. So we have understood that this epsilon rr is a pure function of r. If u is a pure function of r, we are deriving it with respect to r. We cannot get certainly a theta dependence or a z dependence out of thin air. So practically, not practically, if it implies that epsilon rr is just a function of r. Epsilon theta theta is equal to u by r. R is a function of r. U is a function of r. So a function of r divided by a function of r is also a function of r. So epsilon theta is also a function of r. So both epsilon rr and epsilon theta theta are a function of r. Now see how it goes. If both epsilon rr and epsilon theta theta are a function of r, then what about sigma rr and sigma theta theta? They are also pure functions of r. If they are pure functions of r, this equation that we had obtained earlier, there was a partial derivative here. Okay, so this also implies that it is only a ordinary derivative. Okay, so I have written these equations from where? From here. From these two. Basically, I have substituted epsilon rr is equal to du dr and epsilon theta theta is equal to u by r. That's all that I have done. Now, you take these two equations and you feed it into this. You feed it into this. When you do that, the equation that you are going to obtain is as follows. Now, if some of you think that I have mugged it up before coming to class, that is not really true, because I have done it so many times, बस याद हो गया है. Okay. So now when I'm doing these axisymmetric problems, I don't do all of this initial mumbo jumbo, I just start with that equation only. Okay, but your job, you have to actually show this. Okay, yes, you substitute this and you show this. You just prove to yourself that I'm not saying arbitrary things. Okay. Now the thing is, if you do this entire problem for the plane stress case, the intermediate steps will look completely different. The relationship between the stress and the strain that you have over here, it is going to look completely different. In fact, it's going to look something like E divided by 1 minus mu square, then you'll have the terms. But ultimately, when you substitute it and you get the final nice equation, it will again be this equation. Okay. So we'll end the class here, but the thing is, some of you may have skipped, as I have asked you to do it, you derive this thing, you derive that thing. Maybe in the afternoon you feel a little bit lazy, but please do it. Okay, because these kinds of questions, one question will inevitably be there. I'm giving it away. Okay, in the end semester, one question like this is there. I have not yet set the question paper, not a single question of the end semester has been done, but one question like this is there. And that I cannot tell you. That I cannot tell you. The problem with proof that is, some mumbo jumbo is written, and at the end, hence proof double underline. Okay, we'll continue from here next time.